Hello, Malcolm here, and this time I'm going to discuss the quadrilateral problem. This problem looks pretty hard. I guess what it's asking is if we call the sides of our general quadrilateral A, B, C and D, and the length of the diagonals M and N, it's saying, is there some sort of relationship between A, B, C, D and M and N? And as that stands, well, I suspect there is a relationship because that's what the question asks, but I've got no idea what it could be. And what a lot of students would do at this stage is just stop, sit with a blank piece of paper and say, oh, well, I've got no idea. But what a mathematician would do is they would specialise. And in this case, an obvious way to specialise would be to consider not a general quadrilateral, but a particularly simple form of quadrilateral. So for example, we might consider, say, a rectangle, maybe even a square. But let's start with a rectangle and see if that leads us into any insights. So here is our rectangle. So we're now saying, is there a relationship between the sides of a rectangle and the length of the diagonals? So let's do the same labelling as before, M and N. And the important thing about this is that I can see that I have some right angles. So I can see, for example, in the triangle ACD, I've got a right angle there, side A, side B and N. I can say by Pythagoras' theorem, I have a squared plus b squared is equal to n squared. So that's something. I guess in here I can see another triangle. Let's go this way this time. And so now I have A, B, D, and here I have B, C, and M. And again, by Pythagoras' theorem, I have c squared plus b squared is equal to m squared. And so if I put these together, I can see that a squared plus b squared plus c squared plus b squared is equal to m squared plus n squared. Now in my particular rectangle here, I have b is the same as d. So here I can actually say a squared plus b squared plus c squared plus d squared is equal to m squared plus n squared. So that looks like some sort of relationship between the sides, the length of the sides and the length of the diagonals. So the sum of the square of the diagonals is the sum of the square of each side. And so that's true for rectangles. And so now that might give me some idea about what we can do in this general case of the general quadrilateral. Could there be something like that? And so that would give me a way to start. And so I haven't sat with a blank page. I don't suffer from what I call blank page syndrome. I now have an avenue for attack, and I feel good.